Behind me is Pikes Peak, one of the tallest mountains in the eastern Rocky Mountains. And Pikes Peak was the focus of one of the expeditions from some of the European colonists moving west, but they didn't really have much success climbing it at the time. But the eastern Rockies were formed and are still kind of being formed by a convergent plate boundary between the eastern part of the United States and North America and the western part. At the center of this is this area called the Continental Divide. And while the Continental Divide is sort of a divide between two continental plates pushing together, there is also a hydrologic or water-based aspect to it. At some point, going north to south all the way through the Americas, water starts to drain in the Pacific rather than the Atlantic. Because the oceans are on either side of this divide, rivers that are starting in the mountain ranges have to flow somewhere. And on the western side, they tend to flow towards the Pacific, and on the eastern side, they tend to flow towards the Atlantic and the Caribbean. In the rock cycle, metamorphic rock is formed when lots of heat and pressure change the shape of a rock. And usually what this does too is the heat will also change the chemistry of it. Minerals that don't normally fit together, don't normally meet in nature, will suddenly meet as it gets closer and closer to the Earth's mantle, and the heat will kind of melt and squish it together, almost like you're molding clay. You can see the effects of that in the rock behind me. Those little layers that are behind me are from a rock that was pushed up at the convergent plate boundary that's making the Rocky Mountains. And it was pushed up a long time ago. The mountains are still rising, but in this area, plate motion has kind of stopped. And instead, erosion from the weathering of the rain and the wind has started to break apart the rocks and break them down. So what you see is what's left, because normally metamorphic rock forms underground, we can't really see it very easily. But when weathering and erosion breaks apart the top surface layers and the soil and everything washes away, we can see the layers that are exposed underneath. And rather than being neat, flat layers like in sedimentary rock, you see these curves and waves from all of the gravitational pressure that shaped them and the heat which blended different types of rocks together. Behind me is a good example of some of the different striations you can see in rock formations like these. Now, normally these would have been deposited in a flat way, so layer, 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 and probably a lot more space between them. But over a lot of pressure and a lot of heat, because of these convergent plates pushing together, the gravity of the weight of all this rock pushing down on it, and then the heat of the mantle pushing up on it, you eventually get these crazy looking wavy bands of sandstone and granite and many other types of rocks that are all getting pushed and melded together. Colorado got its name from the red colored rocks that are all throughout this particular region. This red sandstone was at one point red granite that made up a lot of the lower layers of the Rocky Mountains. Granite's an igneous rock. It tends to form a lot of times deeper underground, has a lot of crystals in it, and the red color of that granite, once the rocks get exposed by weathering and erosion, forms red sands. And not every rock formation in the Garden of the Gods has that reddish color, and here behind me, as I let the light adjust, you can see this white rock, which has a lot less of the red sandstone and a lot more lighter colored rocks like dolomite that are mixed in. You find sandstone deposited at the bottom of lakes and other bodies of water like oceans, and igneous rock comes from lava, but lava and the bottom of the ocean don't mix very often. So the only reason this is happening is because as all of these different types of rock over millions of years get pushed back into the mantle or near the mantle by plate tectonics, they can find each other. You might have one place where there was a volcano, another place where there was an ocean that dried up, and suddenly both of them are together getting squished by the gravity of the earth and make metamorphic. In the Soul Rock Formation is a good example of the uplifting that happens at tectonic boundaries with metamorphic rocks. So you'll see that some of the layers are like at weird angles, and then you see different colors. A lot of times with metamorphic rocks, the color will actually change to a different color as the rock forms and as the heat changes the type of rock that it is. We call those layers striations. And in sedimentary rocks, they tend to be straight across, but in metamorphic rocks, they tend to be wavy. You also normally only find them in places where there used to be mountain ranges or trenches or other types of bending happening with the crust before it actually melts. So it hasn't turned into magma, it hasn't turned into igneous rock, but it has gotten warm enough to change its shape and its composition.